Okay, guys, I'm ready finally. Picking up in lesson 2.1 for what should be the fourth and final day. Okay, which means the homework, page 169, 13 through 18 all, 24 through 44 evens is what will be due tomorrow. Okay, so that is our current plan. Now, if you recall, yesterday we just looked at some basic transformations, right? We looked at the graph of y equals x squared, that basic parabola, and we practiced our transformations with it, putting multiple transformations together. So not only just moving it left or right or up or down, but also being able to reflect and shrink or stretch. Okay? And that was all if it was with that x squared, so that we could see what was happening. So we're going to continue today. Try and leave that up there a little bit. Talking about vertex form. And vertex form, any quadratic function, f of x equals ax squared plus bx plus c, where a is not equal 0, can be written in the vertex form. So when I'm talking about vertex form here, it's a times x minus h squared plus k. That is the vertex form that we're reviewing today. Okay? The original form of ax squared plus bx plus c, that is our standard form. It's probably what you first learned back in Algebra 1, and we still use it. But this vertex form has some helpful information that can work with us here. The graph of f is a parabola with, and this is why vertex form is so helpful, the vertex is hk. So the nice part about vertex form is your vertex is staring at you right there. Okay, that h and k represent your vertex. So how far you move left or right and how far you move up or down. And then the other thing here is that the axis of symmetry is x equals h. So we got a vertex of hk and an axis of symmetry. If you remember anything about axis of symmetry and the vertex, the axis of symmetry is always x equals the first number from the vertex. Okay, so there's always that connection, and that's what we see there. When finding h, which keep in mind, h is also your axis of symmetry. When finding h, we can use this formula here. So h equals negative b over 2a. They use h equals. I will, instead of h, you will often hear me say x equals negative b over 2a because our axis of symmetry starts x equals. So you can think of it as x equals or h equals. Both work. But that is your axis of symmetry is what that formula is. And that's when we find h. Now, to find k, so to find the second half of the vertex, do you remember what you've done in the past? Once you get that axis of symmetry or that x value, to find y, take the x value and just plug it into the equation. Okay, that's what we've done in the past, is once you have the first half of the vertex, you take it, you plug it into the equation, you find the second half of the vertex. And that still works. And that's what they're referring to right here when it says k equals f of h. That's what that is saying. That's saying if you take h, so the x value, and you plug it into the equation, you'll get k, which is the y value. Now, in the past I've had some people like this one. Right here is another way to find k, or your y value, or your second number in the vertex, however you want to think about that. And that is, to find k, you can use c minus a h squared. I'll be honest, I don't usually use that. However, I'll point it out, and you can try it, and if you like it, you can use it. Okay? It's total personal opinion there. So we'll talk about that here in a moment when we do an example. And then last kind of reminder, a being that number out front, if a is greater than 0, so in other words, if a is positive, we know our parabola will open up. If a is less than 0, in other words, if a is negative, then that means our parabola opens down. And we talked about that yesterday when we had some negatives that reflected and all of that. Okay, so a couple of examples of what we're going to be using this information with. Example 5, and, okay, This should say, I changed that first vertex to standard. That's a typo. You can't use vertex form to find vertex form. Like, doesn't work there. Okay, so we're going to use standard form, which is what they gave us. We're going to use the standard form of the quadratic function to find the vertex and axis of the graph, and then we're going to rewrite the equation in vertex form. Okay, ironically enough, I think I'm going to be teaching this in Algebra 2 today too. I think it's exactly what I'm teaching in Algebra 2 today, believe it or not.
So you taught something like that the other day because I helped Sarah do that homework.
Well, but we didn't go this far with it.
You were doing vertex form.
We were, but we didn't do this. We didn't start with standard form. And that's what I'm going to be teaching today to them. And we're reviewing it today with you guys. So, okay, standard form. F of x equals 6x minus 3x squared minus 5. Now, does anything stand out about that to you? Yeah, it's not in a good order, is it? So my recommendation is, can we first rewrite that? Personal opinion there. If I rewrite this in a better form, what would that better form be? Okay, negative 3x squared plus 6x minus 5. We're being asked to find the vertex and the axis of symmetry. So, can you identify your ABCs?
Yes. A is negative 3, B is 6, C is negative 5.
Okay, you guys with them? A is negative 3, B is 6, C is negative 5. And that's in my mind why it was important to reorder that equation and have it in decreasing order of degrees. Because now I have my ABCs. Okay, so how do I find my axis of symmetry? Okay, she's up here saying something about negative 6 over 2 times something. She's using what? That negative b over 2a. So I tend to write x equals negative b over 2a, which for us is going to be the negative of 6 over 2 times a, which is negative 3. So negative 6 over 2 times negative 3 is negative 6. Negative 6 divided by negative 6? 1. So, what is my axis of symmetry? X equals 1. Okay? Keep in mind, that is also your H value. Okay? So, we found our axis of symmetry. Next job after you find the axis of symmetry is to find the vertex. What do you know about the vertex? The x value is 1. So I know right now my vertex is 1, comma, something. Again, not a coincidence, because my vertex is also HK. How do you want to find the second part of the vertex? In Algebra 2, I can guarantee I taught you to just take that 1 and plug it in. So plug it into what? The original equation. So I'm finding basically f of 1, which is doing negative 3 times 1 squared plus 6 times 1 minus 5. If you are feeling you want to change, what's the other option here today? What's the formula given for k up above? C minus AH squared. I don't know if you like that or not. Give it a try if you want to. Okay, so C minus AH squared. So that would be C minus A times H squared. Okay, if you're doing this my way, what do we have? Okay, I see what I'm like, what? I was going to say -3 plus 6 minus 5. You're in the other order. Anyways, it all comes up to be -2. That -2 is K. And it's the second number in your vertex, yes? However you want to think about it. It's a Y value. It's a K value. It's the second number of the vertex. Those are all equally correct answers. I will accept either of them because they all tell me you know what you're talking about. Well, and that's why I noticed, do I just say H and K here? And I think that's why I struggle with when for axis of symmetry, they give the formulas H equals -B over 2A. Like, I grew up with X equals. I struggle with that too. So, okay. We found the vertex. We found the axis. We have one last thing to do, and that is to rewrite this in vertex form. What is vertex form again? Okay. F of x equals a times x minus h squared plus k. What are the pieces you have to be able to fill in here? A, H, and K. Do I know A, H, and K? Yes. H and K we just found, right? Because we just found our vertex. And where do we get A from? A comes from our original ABCs. You don't have to find A when you're given standard form. A is provided. So, final answer. F of x equals, what's A? -3. X minus, what's H? 1. Quantity squared plus K minus 2. Jace, did you still have a question in there, or are you good?
Because originally I was going to ask why you made H and K, but then I realized, so it's not A equals X minus X.
Right, yeah. I mean, why did they specifically pick H and K? I don't know, but they needed something different is what it comes down to. So. K equals F of H. Okay, so that's technically what we did, or what I did, because that's taking H, so that's taking the 1, and that's plugging it into your equation. That's saying when you take H and you plug it into that equation, it gives you K out. So that's a funky way of saying that's what we've always done. When we take the X value and we plug it into the equation, we get Y. That's what they're saying there. Okay? So you can either take your X value, plug it in, or you can try this C minus AH squared business. Did anyone try that? No? No one felt daring? The first time I taught it, I had a couple of people that really latched onto it and they just loved it. And I was like, really? Whatever, you know. I guess it just comes down to it's another one of those things you have to memorize. Do you need another thing to memorize? Probably not, you know. But
Since the equations are already there,
yeah, there's no reason, you know, unless I guess only if it's a difficult equation to plug into or something, maybe. But
So, Ms. Hartman,
yes,
will we have to remember all of these like equations, or you know, like
all the different forms and equations.
Yeah. We get a paper for that because
I don't know. I don't remember. Let me look and see what I've done in the past and get back with you on if anything, if or what would be provided come to quiz and test time.
Okay.
Because I'll be honest, I don't remember off the top of my head. So that's what I got for you right now. And I don't even really have an inkling of what I've done in the past right now. Okay, notice that next comment before we go to example 6. We can also use completing the square to write quadratic functions in vertex form. It says we learned completing the square in chapter P. We reviewed completing the square in chapter P because we learned completing the square in algebra 2. Okay? It was skipped in algebra 1, almost guaranteed. But it was taught in algebra 2, I know. So that's what we're going to practice. And guys, completing the square, it continues to come up. It's one of those things. It continues to come up randomly in pre-calc. It continues to come up randomly in calc. So you can't say, I don't care. I'm always going to skip completing the square. Work to learn it. It's doable. Yes?
Was there ever an instance where you can use completing the square and not something else? Or like you have to use completing the square. Like that's the only correct way to do it.
You're saying like an alternative?
Yeah. Complete the square.
I mean, there are times where you could do like, if we're solving an equation and we normally use quadratic formula, you could use completing the square instead of quadratic formula. But normally, you'd rather use completing the square as a last-ditch option because quadratic formula we're more comfortable with. So yeah, there are times you could use it that we choose not to. So, okay, use completing the square to describe the graph of f of x equals 3x squared plus 12x plus 11. It says support graphically, check your answer. That's just, you can graph the standard form, you can graph the vertex form we're going to come up with, and if everything's done correctly, they should match. They should be the same when you graph them. Should be in the key word here. Okay, so completing the square. Do we remember anything from earlier this year?
Nope. It has a square.
You're completing something. I think it's complete over 2 square.
Yes, that will be. Hold that thought.
Jog my memory.
Okay, so the whole thought of b over 2 squared, that's what we're going to add to both sides when we get to that point. Okay, so yes, that is there. Okay. So here's the deal. When we are completing the square, your goal is to complete the square, you have to have 1x squared plus bx. Remember, there can be no a value, and there's no c term. You're just using x squared plus bx. In just an equation, where your equation equals 0, that means that we start by moving any c value over and possibly dividing by any a value. Things work slightly different here when I can't move anything to my other side of my equation because it's f of x or y equals. So we're going to work slightly different, but with the same idea. So as I rewrite this equation, first thing is I want to get an x squared plus bx by itself. And I say kind of quote by itself. So first of all, notice on x squared, do we have just a 1x squared? No, we have a 3x squared. I don't want a 3x squared. So what we're going to do is we're going to take 3 and factor it out from our x terms. Okay? So if I take 3 and factor it out, so 3 is a GCF. If I factor it from 3x squared, I'm left with x squared plus 12x. If I factor a 3 from 12x, I'm left with 4x. Yes, I started to give myself away. Now, the next part we have left is a c value. The c value is not part of completing the square. So what I'm going to do is I'm going to leave a gap here and into my parentheses after the 4x. And that c value of plus 11 is going to be scooted over outside of the parentheses. And this is all about setting us up for completing the square.
Why is it 4x?
Because we factored the 3 out of both x terms. Because 12x divided by 3 leaves me with 4x.
Oh.
Okay? So start with, if there is any value on x squared, factor that out of both x terms. Notice I did not factor it out of the c term because the c term's not going in those parentheses. Now, this is still equivalent to my original equation, yes? That's the whole idea, is we're keeping this equivalent with every step we do. I factor the 3 out, move things around, but I haven't changed everything. Okay, so it was mentioned earlier. B over 2 squared. So in a normal situation, we say we're going to add b over 2 squared to both sides. Okay, we're going to have to tinker with that whole add it to both sides, because again, do I have 2 sides to add to here? Not really. But let's figure out what is b over 2 squared here. What is b?
12. Oh, we have to use that.
Okay, so yep, we have to use that number. Okay, so because we need it to be in the form of 1x squared plus bx, b is 4. And so if b is 4, that means you're doing 4 divided by 2 squared. Yeah. So 4 divided by 2 is 2. 2 squared is 4.
So did we not do C or C11?
It doesn't matter.
Yeah,
It doesn't matter.
It's irrelevant.
we only need B.
Right. We need A has to be 1 to make this work. So by factoring the 3 out, I made A 1. And then after you factor that out, that's the B we're using. So B is 4. So 4 divided by 2 is 2. 2 squared is 4. So this is where we say, quote, we add 4 to both sides, right? Now, that means I'm going to add 4 where? In my parentheses. Normally, if I add 4 on one side of the equation, I add 4 on the other side of the equation with my goal to keep it balanced. How do I keep it balanced though if I can't add 4 to the other side of the equation? Subtract 4. So we added 4 here in the parentheses. Down here I'm going to subtract 4 with one slight catch. Last catch. Too many catches? Okay. Is this just a 4? I'm asking, right? So it's not. Why is this not just a 4? No?
Yeah, no, because when you distribute that 3, it's not going to go into the original problem.
Okay. This 4 that I added in the parentheses is in the parentheses that are multiplied by 3. So when I add 4 here, I'm really adding a value of 3 times 4, which is 12. Which means over here, when I subtract the 4, I need to subtract the equivalent value of 4 times 3, which is 12.
It'd be nice to have more than one color. Instead of just,
That's on you at that point.
it's hard.
You know my notes are. And that's why, I kind of underlined there.
Yeah.
Okay. We just have one step left. And that's just the whole idea of completing the square, remember, is that these parentheses will factor. Anytime you complete the square, your next step is to factor that piece into 2 matching parentheses. So think about x squared plus 4x plus 4. How does that factor? X squared breaks into x and x. What multiplies to be 4 and adds to be 4?
2 plus.
Multiplying to be positive, adding to be positive. It factors into x plus 2 times x plus 2, or what we usually write as x plus 2
Square.
quantity squared. Okay, so this 3 stays out front. Parentheses squared. And what I usually say, as opposed to what I just did on the board there, square root of x squared is x. The square root of this 4 over here is 2. It adds to be a positive here, so we need a positive sign. And now we clean up the outside. We have a plus 11 and a minus 4 times 3. Comes out to be minus 1, because it's plus 11 minus 12, so this is a minus 1. Now, what I know by looking at vertex form is that this parabola has a vertex at -2, -1, and it has a stretch of 3. That's what I know by looking at this. Whereas, if I looked at standard form up here, 3x squared plus 12x plus 11, I had no idea. Now, officially it did say to graphically check, yes?
Yeah.
which you might need to go in and turn plot 1 off if you haven't done that. Mine was still on. So my y1, I'm going to type in 3x squared plus 12x plus 11. My y2, I'm going to type in 3 parentheses x plus 2 parentheses squared minus 1. The idea is when I graph these will be the same graph. I'm also, when I go to graph, I'm going to go to zoom 6 because I know my graph is not on a standard 10 by 10 screen. It's on whatever crazy numbers we last used in class. Yeah. So I'm going to do zoom 6.
Are they supposed to? Oh, they are supposed to overlap.
They should be the exact same graph. If they're not the exact same graph, that means either you typed something in wrong or you solved something wrong. Okay? So my side note here that I'm just going to put is graph original and new equations as a check. It's not that there's anything you have to write down. It's not that you need to sketch that graph in or anything, but it's an easy check you can do because you guys have these graphing calculators. Okay, I got one more, example 7. And this is what my Algebra 2 kids did in lesson 4.1. So they've already done this week. So for you guys, it's a matter of remembering, right? And I say that and grit my teeth because you guys are all thinking, really, Mrs. Sargent, you think I remember this? I know. There's a reason I'm reviewing it. Okay. Example 7. Given a vertex of -3, 5 and a point of 2, 1, write the equation for the quadratic function. Okay, so needless to say, we're writing in vertex form. What is vertex form? Vertex form, I just wrote it in. F of x equals a times x minus h squared plus k. And you can say f of x or you can say y. They're interchangeable. So if you would rather say y equals a times x minus h squared plus k, that's fine as well. In order to be able to fill this in, what do I have to know? A, h, and k. Do I know my h and k? Yeah. What's h and k? H and K are my vertex. So H is -3 and K is 5.
So the vertex has to be H and K.
Your vertex is H and K by definition. Now, what do we not know? A. We don't know A, but yet they give us another point. So you know there's a reason they give us another point. How can I find A?
You plug H and K in a software app? No, that's not right. Just kidding.
Well, you plug H and K in, and what can 2 and 1 go in place
you're
of?
X and Y. Oh, I was right. Just kidding.
Okay, so you can use those as X and Y to help you find your A value. You did this a year ago. I know it's a year ago. That says something right there. But so Y equals, which means I'm going to say 1 equals A, which stays A, X minus H.
So 2 plus 3.
2 minus -3 squared plus K
5.
plus 5. Okay, PIMDAS, Aunt Sally, somebody,
Well, first
2 plus 3, which is 5.
Yeah.
5 squared, 25. Now, here's what you have to remember. That 25 is being multiplied by A. So this now writes as 1 equals 25A plus 5. The mistake that some of you you want to make is you want to say, oh, 25 plus 5 is 30. No. That 25 is attached to the A. So if it's 25 times A, I have the equation I wrote. Solve for A, right? If it's 25A plus 5, we're going to subtract 5. 1 minus 5 is negative 4. Then I have 25A equals negative 4. So to get A, I'm going to divide by 25. So we get A by itself, divide by 25, and A becomes negative 4 over 25. Okay, so we've got an H and K. We've got an A. Can you write me an equation? So I'm going to use f of x equals, you can use f of x or y, I'm flexible. F of x equals A, negative 4 over 25, x minus h, which becomes x plus 3, quantity squared, and then plus k, plus 5. So there is your final vertex form.
So we just use that x and y to find our A.
Yes, the x and y are just used to find A, and then you're done with them. Okay, homework, if you haven't started it, you have a few minutes. Page 169, 13 through 18 all, 24 through 44 even. And I have a note in my plans. On 13 through 18, watch, you're looking at a graph, watch what the vertical scale says. Because I don't, it's a graph, and I think it's numbered here. So, and I need to get my book out to understand what my note means. You know. But there's something about the vertical scale that's weird on 13 through 18. Okay, so on 13 through 18, you're matching a graph to an equation. But what it never tells you is that all the vertical scales count by 5s. You end up figuring it out, but it's rather annoying if you ask me. Or wait, that's what I have written down. Let me check. Yes. Yeah, so the horizontal scales count 1, 2, 3, but the vertical scales count by 5s. So that's kind of an FYI there. Yes. Yes.